Hello everyone, myself Dr. Baranilingesan, Assistant Professor, Cadre 3, Department of Electrical and Electronics Engineering, KPR Institute of Engineering and Technology, Coimbatore. So, in this subject electric vehicles, Unit 3 Hybrid Electric Vehicles Technology. In this hybrid electric vehicle technology, we are going to discuss about the control strategy of hybrid electric vehicle technology. So the control strategy is a control rule that is preset in the vehicle controller and commands the operating of each component. The vehicle controller receives the operation command from the driver and the feedback from the drivetrain and all the components, and then makes the decision to use the proper operation mode. The performance of the drivetrain relies mainly on the control quality, in which the control strategy plays a crucial role. In general, there may be a number of control strategies that can be used in the drivetrain for vehicles with a different mission requirement. But in our topic, we are going to discuss about two control strategies. One is that maximum state of charge or peaking power source, or simply we can say it as the maximum SOC of PPS, and engine turn on and turn off or engine on off control strategy. So these are the two control strategies we are going to discuss in this topic today. Let us discuss maximum state of charge. The maximum state of charge of peaking power source control strategy is a strategy to meet the power demand commanded by the driver, at the same time maintain the SOC of the peaking power source at high level. So in this case, here we are going to discuss the topic. So we have to give the power for all the component. At the same time, we have to ensure the battery power should be at a high level. This control strategy is considered to be a proper design for the vehicles for which the performance relies heavily on the peak power source. This includes the vehicle with the frequent stop and go driving patterns and military vehicles for which carrying out their missions is the most important. A high SOC level with guarantee with high performance of the vehicle at any time. The maximum SOC peaking power source consists of the 4 points. One is that point A is called hybrid traction mode, point B called engine generated alone traction mode or peaking power source charging mode, where point C represents the hybrid braking power. So in this hybrid braking power, here we have a regenerative braking power along with the mechanical braking power, and point D indicates that regenerative braking mode. So this is the general diagram of our maximum SOC of peaking power source. In this maximum SOC of peaking power source, so this is our general vehicle speed. So in this general vehicle speed, that line indicates that a maximum traction motor power, the below line indicates that maximum regenerative braking power. So in this maximum SOC of charge, we have a point A here, point B, point C and point D. We know that point A represents the commanded traction power. So in this case, the point A have the following parameters: commanded power, power of the peaking power source, power of engine generator. So the commanded power requires a maximum power. So this commanded power given by the driver, so it is a maximum power. So engine generator can develop the power up to this level. The remaining power can be taken from the peaking power source, nothing but battery. So this is called the hybrid traction mode. So hybrid traction mode, here we have a engine generated power, here we have a battery power. These two power can utilize for the commanded power. So it is called the engine hybrid traction power. Next one, point B. The point B represents the commanded power is less than that of the engine generated power. Here we can see this up to this level of engine can generate power. So up to this level, engine can generate with the full load of power. So the commanded power is required is very less compared to the engine generated power with the full load. So remaining power can be utilized for the purpose of the charging of the battery. So that is mentioned as the PPS charging. So PPS charging is nothing but peaking power source charge. So it is called the either it's going to be a engine generated alone traction mode, or else it's going to be a peaking power source charging mode. That is mentioned in this point B. Next we have a point C. The point C represents the commanded braking power. So this is the commanded braking power. This commanded braking power is greater than that of the braking power that the electric motor can produce. So this is our electric motor can produce the power, so it is called the regenerative braking mechanism. But in this concept, the commanded power is much greater than that of the uh, motor electric motor power. So here we are going to use the mechanical braking power also. So it is combination of electrical braking power along with the mechanical braking power. So that is the point C represents the hybrid braking mode. So this hybrid braking mode consists of the both the electrical braking power as well as the mechanical braking power, and this point D represents the commanded braking power. This is the commanded braking power less than that of the electrical braking power. Here we can see here the commanded braking power is here, the electrical braking power up to this level. So the commanded braking power comparatively less than that of the electric braking power. So this is known as the purely regenerative braking mechanism, that is mentioned here, regenerative braking mode. During the regenerative braking mode, the battery is going to be a charging state. So that is the explanation of this diagram. So these are all the point A, point C and point D representation of the diagram. Next we are going to see about the control flow chart of the maximum SOC of peaking power source control strategy. So with the continuation of the previous diagram, so here we have a traction power command, so here we have a braking power command. So these are analyzed with the help of loop operation, either going to be a traction or braking power. If it is a traction means it going to be a traction power is less than that or greater than that of the engine generated power. Here the engine generated power is greater than that of the traction power, so that is going to be a state of peaking power source charging. If SOC is less than that of the SOC top, so maximum, which means that SOC is a maximum, and which is less than mean it's going to be a charging mode of operation. Or else for this condition, coming to the point of traction power command as well as the braking power command, if it is a traction, then comes here, it is compared with the engine generated power, traction power which is greater or less. If it is lesser, then it's going to be a hybrid traction, which means that engine generated power along with the battery power can be utilized. So this is indicates the point A. Where in case of if not, it going to be another condition. So in this condition, it going to be a engine generated alone traction, so it's a point B. Next here we have a hybrid braking mechanism. So in this condition, if not satisfied, then it's moved to the point of P brake, which is greater than that of the motor maximum power. So if the condition is satisfied, it is called the hybrid braking. So hybrid braking means we know that mechanical braking as well as the electrical braking, so it represents the point C. If not, it going to be a regenerative braking. So with the continuation of this previous diagram, so this control strategy is used here. Next we are going to discuss about the thermostat control strategy. So this is the topic which is not related to that of maximum SOC. It is little bit different from the maximum SOC charging. So maximum SOC of PPS control strategy emphasizes to maintaining the SOC level state of charge of the peaking power source at to be a high level. However, in some driving conditions such as long time driving with a low load on highway at constant speed, the peaking power source can be easily charged to its full level, and the engine generator is forced to operate with the power output smaller than its optimum. Hence, the efficiency of the drivetrain is reduced. In this case, engine on-off thermostat control strategy can be used. This control strategy is shown in the following diagram. You can see here. Here we have a engine operation. It is mentioned as on and off operation. Here we have a peaking power source. The peaking power source denoted between the line of peaking power source SOC top line and peaking power source SOC bottom line. Whenever the engine is on, the peaking power source SOC going to be charged, which means that battery is going to be charged to the top line. Once it reaches top line, the engine generator is turned off. Once it reaches the maximum level, the engine generator is turned off. So if it is turned off, then the vehicle propelled only by the peaking power. So if its engine is turned off, if it meets the condition here, the engine will be turned off here. From this position to this position, this peaking power source only going to propel the vehicle, so the battery is going to be drained. So once it reaches the peaking power source SOC of the bottom line, again the engine generator going to be turned on, again the battery is going to be charging here. Here we can see that the charging and discharging should not be a uniformly or linear fashion, because of the depending upon the different road condition, it may be a it may not be a smooth operation. So the PPS gets charging from the engine generator. In this way, engine can always operate within the optimal deficiency region. That is mentioned in this point also. Thank you.